Müller-Lyer Illusion. This illusion features two lines of the same length, each with opposite patterns of arrow-like ends. One line has arrowheads pointing outwards, while the other has arrowheads pointing inwards. The lines appear to be of different lengths due to the orientation of the arrowheads. The brain interprets the outward-pointing arrowheads as a sign that the line is shorter, and the inward-pointing arrowheads as a sign that the line is longer, creating the illusion. Ponzo Illusion. In this illusion, two horizontal lines of equal length are placed between two converging lines, like railroad tracks receding into the distance. The upper horizontal line appears longer because the brain interprets the converging lines as perspective cues, making the upper line seem further away and therefore larger. Ebbinghaus Illusion. This illusion shows two identical central circles, each surrounded by other circles. One central circle is surrounded by larger circles, while the other is surrounded by smaller circles. The central circle surrounded by larger circles appears smaller, and the one surrounded by smaller circles appears larger due to relative size perception influenced by the surrounding circles. Zollner Illusion. The illusion consists of parallel lines intersected by short diagonal lines. The short lines are arranged at alternating angles. The parallel lines appear to be non-parallel due to the angles of the short diagonal lines, which distort the perception of parallelism. Café wall illusion. This illusion shows a checkerboard pattern where the parallel horizontal lines appear to be sloped. The arrangement of the alternating black and white tiles and the offset of the tiles in each row create the illusion of sloping lines, even though they are perfectly parallel. Kanizsa Triangle. This illusion shows three Pac-Man-like shapes arranged in such a way that they suggest the corners of a triangle, even though no triangle is actually drawn. The arrangement of the alternating black and white tiles and the offset of the tiles in each row create the illusion of sloping lines, even though they are perfectly parallel. Rubin Vase. This classic illusion can be seen as either two faces in profile looking at each other or a vase in the center. This is an example of figure ground perception, where the brain alternates between seeing the foreground, faces, and the background of vase. Poggendorff Illusion. This illusion involves a straight line intersected by a rectangle or other shape, causing the line segments on either side to appear misaligned. The brain incorrectly interprets the continuation of the line due to the intervening shape, which disrupts the visual path. Ames Room. A specially constructed room where people or objects appear to change size as they move from one corner to another. The room is trapezoidal rather than rectangular, but it is viewed through a peephole that makes it look normal, causing the size distortion due to the altered perspective. Shepard's tables. Two tables with different shapes appear to be of different sizes, even though their surfaces are the same size and shape. The illusion is caused by the perspective cues and the angles of the table legs, which mislead the brain into interpreting the tables as having different dimensions. Lilac Chaser. A circle of lilac-colored dots appears to have a moving green dot when the lilac dots are sequentially removed. This illusion occurs due to negative afterimages and the brain filling in the gaps with the complementary color, green, while focusing on the black cross in the center. Herring Illusion. Two straight parallel lines appear to bow outward when placed over a background of radiating lines. The radiating lines create a perception of depth and perspective, causing the parallel lines to appear as if they are curving outward. Motion Aftereffect. After staring at a moving pattern, such as rotating spirals, a stationary scene appears to move in the opposite direction. This occurs because the neurons in the brain that detect motion become fatigued, causing the subsequent stationary image to appear to move in the opposite direction. Troxler Effect. When staring at a fixed point, peripheral images fade and disappear over time. This effect happens due to neural adaptation, where neurons in the brain stop responding to unchanging stimuli, causing the peripheral images to fade from perception. Fraser Spiral. A series of overlapping arcs creates the illusion of a spiral, even though it is made up of concentric circles. The alignment and angles of the arcs create a misleading perception of continuous spirals, even though they are actually circles. Jastrow Illusion. This illusion features two identical shapes, one positioned slightly above the other. When aligned, the lower shape appears larger than the upper one. The brain interprets the lower shape as larger due to its position and the context provided by the other shape, even though both shapes are the same size. Hermann Grid. A grid of black squares on a white background with white lines intersecting at right angles. Small gray dots appear at the intersections. The gray dots are an illusion caused by the way the brain processes contrast and brightness. The surrounding black squares create a visual effect that makes the intersections appear to have gray dots, which disappear when looked at directly. Watercolor Illusion. This illusion consists of a black and colored line adjacent to each other, creating the appearance of a wash of color spreading into the enclosed area. The brain perceives the color as filling the space between the lines due to the luminance and color contrast, creating a watercolor-like effect. Checker Shadow Illusion. A checkerboard pattern with a shadow cast by a cylinder. A square in the shadow appears darker than a square outside the shadow, even though they are the same shade of gray. The brain adjusts for the shadow and interprets the color of the squares based on context and lighting cues, causing the illusion of different shades. Pinna-Brelstaff Illusion. A series of concentric circles with radial patterns that appear to rotate when the observer's gaze moves across the image. The movement illusion is caused by the interaction of the radial patterns and the way the brain processes motion and contrast. Snake Illusion. A static image with a pattern of snakes that appear to move and wriggle when viewed. This illusion results from the brain's motion detection mechanisms being fooled by the high contrast, repetitive patterns in the image. Impossible Trident. An object that appears to have 3 cylindrical prongs at one end and 2 rectangular prongs at the other, creating an impossible figure. The brain attempts to interpret the 2-dimensional image as a 3-dimensional object, but the conflicting visual information creates an impossible figure. Hollow Mask Illusion. A hollow mask of a face appears as a normal, convex face when rotated or viewed from certain angles. The brain's familiarity with faces being convex overrides the actual visual information, causing the hollow mask to appear convex. McCollough Effect. After viewing colored gratings for a few minutes, black and white gratings appear tinted with the complementary color. This after effect is caused by the brain's adaptation to the color and orientation of the gratings, leading to a temporary color tint in the complementary color. Necker Cube. A wireframe drawing of a cube that can be perceived in 2 different orientations. The brain alternates between 2 possible interpretations of the cube's orientation, causing a reversible perspective. Thatcher Effect. An image of a face with the eyes and mouth inverted appears normal when the face is also inverted but looks grotesque when viewed upright. The brain's ability to process faces is disrupted by the inversion of facial features, making the distortion more noticeable when the face is upright. Mach Bands. A series of adjacent rectangles with uniform color gradients that appear to have bands of increased brightness at their edges. This illusion is caused by the brain's lateral inhibition, where the contrast at the edges is enhanced, making the bands appear brighter. Cornsweet Illusion. 2 adjacent regions with a gradient that smoothly transitions from one color or shade to another. One side of the boundary appears lighter, while the other side appears darker, even though the actual gradient is continuous. The brain exaggerates the contrast at the boundary between the 2 regions, leading to the perception of distinct light and dark areas despite the smooth gradient. Orbison Illusion. A set of concentric circles or a grid pattern appears distorted or warped when overlaid with a central figure or lines. The distortion is caused by the brain's attempt to interpret the overall figure in the context of the grid or circles, leading to a misperception of the underlying shapes. Hybrid image. A hybrid image is an optical illusion that combines 2 different images into one, creating a visual effect that changes depending on the viewer's distance from the image. When viewed up close, one image is clearly visible, but as the viewer steps back, the second image becomes more prominent. The hybrid image illusion works by blending the high spatial frequencies, fine details, of one image with the low spatial frequencies, broad shapes and colors of another. Thanks for watching. Subscribe if you liked the video.